Okay, so let's talk about the different types of floods that we're going to look at. So there's really just two major types we want to kind of categorize. One is the flash floods. So these are also referred to as upstream floods. You might be familiar with them if you live in Arizona. So here we tend to have some reasonable topography, some steep mountains, and so we tend to have younger part of the streams, these streams that are steeper, have a higher velocity. Now, of course, um, climate also plays a role. We don't get a lot of rain. We don't have a ton of streams flowing around that have developed over long periods of time. So what we see is the upper part of the drainage basin is typically more prone to flash floods. And so it's caused by usually an intense rainfalls over a short period of time. It's usually impacting a small area. And so, like I said, if you live in Arizona, you've probably experienced these, you've seen these, they come racing down. Sometimes these small washes and gullies, and they cross roadways and things like that. Up in the mountainous regions, they can be more severe. And so, the difference between these types, which are upstream floods, and what are we calling downstream floods is usually the size, the area that's impact, the duration, how long they take. So these are usually pretty short and sweet. And so we tend to get them in arid environments like us, where there's not as much vegetation. And so, of course, they can be some natural things. Right? Heavy rainfall in a short amount of time can lead to some flash flooding, but they can also be things that occur like a break of a dam or a levee, things like that, where there's some human induced reasons why there'd be a flash flood. Um, in places like this, we have heavy rainfall, moves downslope quickly, moves into a stream, and causes a flood relatively quickly. Um, there are some flash floods that we can attribute to some failures of structures. And so, certainly, when we're talking about disasters that happen. There are plenty of big regional floods that have occurred, but some of these listed here are disasters that have occurred because of dam failures. So there's a couple links in the next couple pages that take you to some of these. So some are construction problems, some are geology problems, some are just extreme weather problems that are really difficult to control. And so one of the examples is this St. Francis Dam collapse. So you can take a look at this link here and get some of the more details. But really quickly, you can see that some of the reasons in this little report why the dam failed. So once again, in this class, we don't go crazy into the rocks and minerals, but if you look at some of the rocks that are exposed where the dam was placed, we see that there is some what's called gypsum, which is a rock that can dissolve in water over periods of time. There is a fault here, which is a fracture surface, which is a weakness in the rocks, but also can allow water to move through. There's other material that gets kind of weak when exposed to water. So certainly the geology of the area didn't really lend itself to putting a dam here. Now, whether the officials knew when they were constructing the dam about the geology of the area or not, it's unclear. But certainly we can look back and say maybe this wasn't the best place for the dam. So looking at the geology, of course, is something that is done now for sure. You need to evaluate the rock types and how they handle the stress and the strength and the water and all that kind of stuff. There's another example here of some geology problems. Once again, you can click the link to read a little bit about this, but in this case, heavy rainfall caused with a landslide actually, but the material that was on the sides of the slope where they built the dam in a small little notch area and then filled up the reservoir, allowed water to get into the side slopes here. Because of the geology, here you see the bedding, the layers are tilted inward toward the lake. And of course, over time and heavy rainfall, there was a big storm and it caused this to fail and actually moved down slope into the lake and caused a small tsunami. And so the wave that was generated by this material splashing into the lake is like that Latoya Bay one that we saw last week, where in Alaska, there was a landslide that made a local tsunami. That's kind of what happened here. The wave actually overtopped the dam and then flowed down into the valley here where the people were. And unfortunately, there were people that were injured and killed from that event. So we certainly see these fast moving flash flood events that occur when we have either a heavy rainfall that generates lots of water over a short amount of time or some catastrophic failure of some structures. Now, when we talk about um, regional floods, downstream floods, right? We're talking about an event that covers a huge area. So now we're impacting more people, but it's not a fast and furious event. It usually takes a long time to build. And in the case of if we look at where the Mississippi River is, and there's certainly been some flooding on the Mississippi River, it has inputs from lots of different rivers. So heavy rainfall along the Ohio and the Missouri and other rivers can bring lots of water into the system and overwhelm the system. But down here in Vicksburg, it would take time for all that big amount of water to make it down here. So you can predict, see that it's coming, slowly see the water rising, realizing that there will be a flood and there's a certain amount of water coming your way and you can prepare for it. But of course, it's also larger and it could impact lots of people. And if we're looking at some type of little hydrograph to illustrate the difference. The big thing about upstream is they happen quick, so this is time, remember. So the amount of water comes in quick and leaves quick, as opposed to a downstream flood where we have this more gentle kind of buildup of water. It tends not to be as big in the end, but it lasts a lot longer. And so for those, we're looking at these meandering streams. And so levees are usually built alongside these streams in preparation for the eventuality of a flood. And we use the data, we use the recurrence interval and probabilities to help predict, and of course, weather forecasting and all those things to try to combat, the impact of a big type of event like this on society. And just to give you an idea of how common these big flooding events are, this is a map that's just showing you when a disaster was declared from flooding. The different colors represent the different amounts. So in the green areas, there has been at least one instance where a disaster was declared based on flooding. And of course, the yellow is 2, the orange is 3, and the reds are 4 or more. So you can see there's lots of places that have experienced some type of disaster related to flooding. Okay. Should we take a break already? Okay. Let's do it, and then we'll come back and grab another one.